have the opportunity to already receive the object temperature and the internal sensing head temperature via the PLC after the integration of the GSD file. To be able to receive and send order furthermore, you will need a so-called Telegram mode, which you can implement into the PLC settings as a module. You will be able to send further orders from the PLC to the temperature sensors and receive corresponding answers from the sensors to the PLC with the support of the Telegram mode. Additional orders can, e.g., be the change of the emissivity at the temperature sensor or the setup of an alarm figure. Within the next examples, I will show you the appropriate approach for the sending and receiving of a telegram. The principle is always the same. 10 bytes will be sent to the temperature sensor. The PLC will receive a replay from the sensor with the corresponding 23 answers bytes. The first byte consists of a handshake command. This command needs to include a different address after each completed sending and receiving process. The second byte is the Profibus command 47. This command informs the temperature sensor that a following command will be sent. The third byte includes the actual command with the statement which setting of the sensor will be changed or which information will be requested from the sensor. This could be the changing of the emissivity of the sensor or a request of the alarm values which will be adjusted at the temperature sensor. On this website, which also includes the webcast regarding the Profibus, you will find the videos as well as the command list for the temperature sensors Optris CT and Optris CT laser, which include all commands covering the sending and receiving. Let's have a quick look at some commands from the list. To request, e.g., the transmission parameters, which is set in the sensor, the value 0.5 is sent as a hexadecimal figure. To change the transmission degree, the hexadecimal figure 85 is sent to the sensor. This document includes additional other examples beside the complete command list. With the next bytes, the parameters will be sent which need to be changed at the temperature monitor. These parameters can contain up to 4 bytes. If not only one value will be requested from the sensor, but a complete setup of the sensor will be done, the corresponding XOR checksum must be transferred too. As already mentioned, 10 bytes must be sent from the PLC to the temperature sensor. The missing bytes will be filled with zeros. The telegram can only be sent to the temperature sensor in this order. The temperature sensor will replay with an answer after receiving the telegram. This answer contains 23 bytes. The first byte hands back our so-called handshake byte. Then the second byte follows with the value 15, which points out that we have received a telegram. The third byte is the answer byte from the temperature sensor. This is always the value 67. Afterwards, either the answer values from the sensors will follow if a request was sent, or the values of the change will be received if a request for new settings at the sensor was sent. As 23 bytes must be sent and received by the PLC, the missing bytes will be filled by zeros. Let's have a look at an example. In this case, we will change the emissivity of the temperature sensor to 0.95. The first step is the sending of a handshake byte. In our case, this byte has the value 02. The second byte is the Profibus command 47, who informs the temperature sensor that another command will be sent. The third byte includes the actual command, with the specification which settings at the sensor will be changed or which information will be requested from the sensor. Let's have a look at the command list again. To change the emissivity of the sensor, the command 84 is needed. With the following bytes, we will submit the value which will be changed at the sensor regarding the emissivity. The new emissivity of the sensor will be 0.95. As we cannot transfer floating decimal numbers, the value 0.95 must be multiplied with 1000. We will then receive the value 950 as a decimal digit. This value needs to be converted into a hexadecimal figure. We will open the Windows calculator to do so. 950 as a decimal digit is 03B6 as a hexadecimal figure. 03B6 will therefore be our next two bytes which will follow in the telegram. As we will not read out a value from the sensor but will change a value, the emissivity we need to add a checksum as well. This XOR checksum will be shaped through the third byte and the value bytes. In our case, this checksum is 84 XOR 03 XOR B6. Let's have a look at the result byte which we generated with the help of our Windows calculator. 84 XOR 03 XOR B6 results in the byte 31. The remaining bytes which are needed to receive the 10 bytes for the sending of the telegram will be filled with zeros. This will be 4 bytes in our case. The completed telegram can now be sent off. The temperature sensor answers immediately with an answer telegram consisting of 23 bytes with which the changed emissivity will be confirmed. The confirmation looks as follows. The first byte hands back our so-called handshake byte. In our case, it's 02. The second byte sends back the value 15, which says that the telegram was received. The third byte is the answer byte from the temperature sensor with the reference that the following bytes are containing the modified information. This is always the value 67. Afterwards, the parameters bytes will follow with the value which was changed at the sensor. In our case, the values 03B6 are received. The emissivity was changed to 0.95. The missing bytes to come up to 23 bytes will be filled up with zeros. Here we can see the complete sending and receiving telegram within the SIGMATIC software. The green area shows the 10 bytes which have been sent. The 23 bytes are shown in the red area which were received by the PLC.